Welcome in dark core. In recent years, summer temperatures in Europe have reached over 46 degrees Celsius, 115 degrees Fahrenheit. It has snowed in South Africa, and the temperatures there dropped to -10 degrees Celsius, 14 degrees Fahrenheit. While some scientists say to prepare for severe heat waves, others predict a new ice age or a sharp cooling period is coming that will last millions of years. Throughout the 4.5 billion years of its existence, the Earth has repeatedly experienced ice ages, and a severe cold may arrive again soon. Will the planet Earth freeze over again, and what does humanity have to worry about? INTRO, you will probably be surprised, but an ice age on Earth has already begun. Fortunately, we're not in the middle of one, but instead we're in a geological interval of warmer global average temperature called an interglacial period. And when this ends, the real cold will come. So when will this happen? Researchers are trying to find out by studying previous glacial epochs. An analysis of ice samples drilled from the permafrost of Greenland and Antarctica helps to reveal information about the last 800,000 years. Sediment at the bottom of the oceans allows us to look even further, tens of millions of years back into the Earth's past. And the incredible secrets of climate change hundreds of millions of years ago have been revealed by studying the sediment and rocks. Scientists have found that the first, Hu times Rho times Ni times and high RNN, Uranian ice age began about 2.4 billion years ago. At the time, the planet received about 15% less sunlight than it does today. In addition, primitive algae emitted oxygen, which displaced methane, a powerful greenhouse gas in the atmosphere. Then the Earth froze for nearly 300 million years. But at the equator, there were still areas without permafrost. The next ice age, Crowdianin, the Cryogenian, wasn't so mild. This era marked the most severe cold in the history of our planet. It began about 720 million years ago. Even at the equator, temperatures rarely rose above -20 degrees Celsius, -4 degree F. -50 degrees Celsius, -58, and below became the new norm for the rest of the world. Scientists believe that even the world's seas were frozen to the very bottom. At the poles, dry ice or solid carbon dioxide appeared on top of water ice. From space, the Earth probably looked like a huge snowball. Check out this NASA image taken by the Cassini spacecraft. This is what Saturn's moon, En times Cell times A times 2 Enceladus, Enceladus looks like. Its snow-white surface reflects 99% of the sun's light. And scientists think the Earth was just about the same during the Cryogenian period. Only bacteria and algae near a few hot springs survived this ice age. The cold returned again during the Paleozoic era. Called the Andean-Saharan, the ice age began about 450 million years ago, and lingered for 30 million years. But it was nothing compared to the Cryogenian. 3-kilometer, 1.8-mile, glacier occasionally rolled up to subtropical latitudes, but in general, the temperature was only slightly colder than today. However, everything ended in disaster called the Great Dying or the Permian Extinction, the largest mass extinction in the history of Earth. According to one hypothesis, the thawing of the Earth at the end of this ice age led to the explosion of a so-called methane hydrate bomb. When methane frozen in the ground warmed, it hit the atmosphere like a huge fountain, displacing a significant part of the oxygen from the atmosphere. This resulted in unfavorable conditions for life. 70% of terrestrial and 96% of marine life forms went extinct. Scientists are still looking for what causes global cooling. They discovered that a decrease in the activity of solar flares played a huge part in this. As the planet received less heat and light from its star, the Earth's temperature dropped. To test this theory, American physicist Robert Ehrlich created a computer model of solar plasma behavior. It turned out that its fluctuations coincide with the periodicity of glaciation on Earth. The light of the sun is sometimes obscured from us by galactic gas and dust clouds. Our climate is also affected by changes in the Earth's orbit and its axial tilt. This is shown in the astronomical model of ice ages proposed by the Serbian scientist Milutin Milankovic. It calculates fluctuations in the inclination of the Earth's axis under the influence of the Moon's gravity and the other planets of the solar system. Similar events occur every 26,000 and 41,000 years. In addition, changes in the Earth's orbit have a cycle of 93,000 years. Our planet revolves around the Sun in an ellipse, first approaching our star, then moving away from it. The model calculates that the Earth receives 5 to 10% less heat at the maximum distance from the Sun, as well as during the largest axial tilt, combined with minimal solar activity. When this happens, an area of glacier increases and, like all white surfaces, reflects the Sun's rays back into space. This makes our planet even colder, and glaciers start growing in size again. The process continues for millions of years. The Earth is also periodically cooled by volcanic eruptions. Their emissions pollute the atmosphere and trap sunlight. The world ocean absorbs carbon dioxide that warms the atmosphere. Meanwhile, continental plate shifts form mountains. And steep mountain ranges can draw carbon dioxide out of the atmosphere. As erosion exposes new rock, it leads to a chemical reaction between minerals on hill slopes and CO2 in the atmosphere, weathering the rock and using carbon dioxide to produce carbonate minerals. According to scientists, a combination of all these factors caused the last ice age. It started about 35 million years ago in the current CE times no times so times IC Cenozoic era. The late Cenozoic ice age is characterized by a frequent alternation of incredibly cold glacial and rather mild interglacial epochs. The Earth has been in the interglacial period called the Ho times low times Cene HLSN Holocene epoch for 11,700 years. But the weather during this period can also change. Warm millennia are replaced by cold ones. The last epoch of strong glaciation began about 110,000 years ago and ended 9,700 to 9,600 years ago. After that came the thaw, which replaced the Little Ice Age that lasted between the 14th and 19th century. In terms of average annual temperatures, it was the coldest time in 2,000 years. Researchers associate the Little Ice Age with the slowing down of the Gulf Stream around the year 1300 AD. Due to severe winters with abnormal frosts in Europe, gardens froze, and cold spring rains destroyed vegetables. By 1350 AD, the Great Famine broke out and lasted for 2 decades. By the end of the 19th century, a thaw arrived again, which has lasted to this day. But eras of strong glaciation usually return every 10,000 years, so we're running out of time. And some scientists predict an intense cold in the near future. So how is this possible when temperatures on Earth are only rising, glaciers are constantly melting, and mankind is actively fighting global warming? We have emitted an incredible amount of greenhouse gases into the atmosphere. So far, this is holding back the advance of glacier. And yet, according to many scientists, nature will take over. But this may not happen for another 100 or even 1,000 years. However, some scientists think that global warming is actually bringing global cooling one step closer. One model of climate change showed maximum warming of the Arctic Ocean. Freed from ice, water evaporates and falls in the form of snow into the subpolar regions. New glaciers are forming. Scientists believe that in the end, the warm Gulf Stream will not be able to break through their barrier from the Atlantic to the polar seas. Then the ice sheets will begin to grow rapidly. Whenever this new ice age comes, it will undoubtedly change the Earth, like what happened during the previous glaciation over 10,000 years ago, when glacier redrew the landscape of our planet. They compressed many mountains and hills with their weight and destroyed vast areas of soil. Ice sucked water out of the oceans, lowering sea levels. Many rivers transformed into huge valleys and lakes within continents. Land bridges appeared between continents. Canada, Scandinavia, the British Isles, most of northeastern Europe, and Russia were under ice sheets several kilometers thick. If such conditions happen in the next ice age, humans will have a rough time. According to some hypotheses, the temperature at the equator would drop by about 10 degrees Celsius, 50 degrees Fahrenheit, and in the north and south down to minus 50 degrees Celsius, 58 degree F. In vast areas, the cold would destroy crops and lead to a massive famine. A similar thing happened after the eruption of the Toba supervolcano 74,000 years ago. According to researchers, only 2,500 of our ancestors managed to survive the long volcanic winter. The entire global geopolitical order would also be turned upside down. The borders of most countries would change due to lower sea levels. According to scientists, the ocean level would descend by 150 meters, 490 feet. Malaysia and most of the Indonesian islands would be united into a single land mass. Sri Lanka would once again be connected to India by a surface land bridge. And Ethiopia would merge with Yemen. Water bodies would also change dramatically. Perhaps, the Mediterranean Sea would become cut off from the global ocean. Not a single port in the world would be able to accept ships because the ocean waters would roll away from those ports. But what would happen to North America and Europe? Imagine if you lived in Florida and California where the sun shines all the time, and walking out one morning and seeing the landscape of Alaska. Such climatic conditions would even happen in the south of the United States. Almost all grain crops wouldn't survive there, and food supplies would quickly run out. Those lucky enough to find food would perish from the cold because power stations couldn't survive long in such cold and would be shut down. Buildings would fall into disrepair and eventually collapse. Huge crowds of people would move south. Australia, New Guinea, Sub-Saharan Africa, and Southeast Asia would continue to have a warm climate suitable for agriculture. There, new islands suitable for life would form within the ocean. And India and Brazil would probably have the status of world superpowers. The temperate climate and the lowering of the ocean levels would give these countries a huge amount of new fertile land. But would they be able to feed billions of refugees? Some experts believe that they wouldn't. Battles over food would begin with residents of countries with a favorable climate. Currently, the situation isn't that scary, because over the last centuries, the development of our civilization has literally skyrocketed. If we have mastered space and visited the moon, then why couldn't we cope with the cold? There are already a lot of interesting ideas about how to survive the upcoming ice age. One idea is to add greenhouse gases to the atmosphere to warm up the planet. And chlorofluorocarbons might just be what we need. This mixture is much more efficient than CO2. Systems like fusion energy could also help to keep the Earth warm. They are designed for Arctic conditions and work based on nuclear fusion reactions. Glacier could also be utilized to generate electricity. A mile-high wall of ice would inevitably begin to melt on hot days. And water falling from a height of 1,500 meters, 4,900 feet, or more can provide tons of energy. Giant hydroelectric power plants on rails would likely run parallel to a mega glacier, with pipes mounted to its top. Turbines would extract energy from the falling water, and then distribute it to eco-farms at the base of a glacier. With the help of genetic modification, unique varieties of crops that are resistant to severe cold could be developed. Farmers would have the opportunity to have good harvests. Then it would be easier for people to adapt to life in regions covered with ice. In the end, the Enjat Inuit people did it without any benefits of modern civilization. Although many would still move to a warmer climate. The use of intensive technologies in agriculture would make it possible to feed as many people as necessary. However, after all, we may not need all this. A mild ice age is another possibility. Or the next ice age could take some other, completely new form. Nature can turn a specific region into a giant desert. Scientists say that now a huge amount of greenhouse gases pollute the atmosphere with particles of various substances. These gases don't allow the sun's rays to reach the planet, but instead warm up the atmosphere. When a lot of these substances accumulate, the Earth could become a huge, baked Alaska desert, cold and icy on the inside, but with a warm outer layer consisting of the atmosphere. Scientists have yet to find out which scenario of the next ice age is most likely. But whatever the case, the entire history of the Earth is a series of cold and warm epochs. Judging by the previous cycles, winter is close. And it depends on our preparation whether humanity can survive an upcoming catastrophe. What do you think should be done first? Tell us what you think in the comments. Make sure to stay tuned here for more exciting things about our planet and the universe, and we thank you for watching Dark Core.